Question number 6 of the PhilNITS FE afternoon portion of the exam. In this question, we have a function called count1. It receives a bit 8 type argument byte and returns the number of bits 1 in the argument. Okay, what that means is if our function count1 receives as input this set of bits, and it should be 8 bits because a byte would have 8 bits. You can say 4 and then 4, so 8. The return value is 5, and the reason why it's 5 is because if you count the number of 1's, there should be a total of 5 there. 1, 2, 3, 4, and then 5. The other thing too that we have to take note of is the operator ampersand, which represents a logical product, and also another operator, a pipe, which gives us the logical sum. We have another one, this one, which means a logical shift to the right, and another one which means logical shift to the left. Okay, it gives us example. For example, V logical shift to the left and means that it's going to perform a logical shift of the value of V by n bits to the left. Okay, next we need to look at the program to see what exactly are we supposed to answer, and we can find a blank here, and we need to choose which among the choices is the correct answer. In this case, I was able to choose the correct answer, which is letter A, and we need to know why it's the correct answer. Of course, you may try out the other choices too and see if they're gonna give you the correct answer. And really, the point of having to test your idea is something that we need to emphasize, and because we know that people can come up with all sorts of ideas, but when you put in the values, they find that the result doesn't quite give them the output that they are supposed to get. And that's why in this case too, even though I was saying that this is the correct answer and I thought of thinking about whether this is really the correct answer or not, and so on and so forth, really the best thing that we should do is put in the values and see what the result would be. Now, if we look at the program, we have here the function count1, and then the byte is the input. We put it here in our own variable inside the function, and then the r is set to 0 at the start, and then we have an I here to go for the increment, because we need to go through each of the bits, and we start off from 1 to 8 and we count by 1. In this case, again, we are starting at 1 and not at 0, because I know if you get used to starting at 0, you might find this one a little bit disconcerting in a way, but I think you can adjust and think about this in this term, where you got 1 at the start and then going to 8, counting by 1. Now I put in the correct answer in the if statement, and take note that what we are going for would be to not get a 0. The output here should not be equal to 0 so that we can do an add, because we need to count how many 1's are in the input. Okay, now if we are gonna put here the input, which is 11001011, remember in our description here, this one, we are gonna test if we are gonna get 5 as the return value. And in this case, if we look at this part and we're starting at 1, then 1 minus 1 is 0. Therefore, we are going to do a logical shift to the left by 0, but 0 is not going to do a logical shift as another number like 1. So in this case, we just keep it as is. And then in this part, want to know if this one would give us a 1. And what we can see is 1 and 1 would give us a 1. And that's why we get a +1 for the R. The rest here is 0. So 1 and 0 is 0. 0 and 0 is 0. Okay, and if you're wondering how I know that, we'll look into the table that I put up here. Just as a reminder, if you've done something related to logical operations, electronics, gates and things like that, then I think you should remember something about this as well, where if it's 1 and 1, a logical product, the output would be 1. 1 and 0 is 0. 0 and 0 is 0. If you got a logical sum like this, which I think can be said to be 1 or 1, then it would be 1. 1 or 0 would be 1. 0 or 0 would be 0. Okay, so if you remember this, then this question shouldn't be too difficult for you. And again, we have to go through at least a few numbers to see if it's still holding up our idea. So we move on to the next number, which is 2. 2 minus 1 is 1. And we do a logical shift to the left by 1. And that's why the 1 that was previously here will be put to the logical, will be shifted logically to the left. And therefore, we can do a logical product to see if we can get a 1. 1 and 1 gives us a 1, and that's why we have to add a +1 to our R. This part here is the same as the input here, okay? This one is the only thing that we are shifting to the left, okay? So next, 3. 3 minus 1 should give us 2. And therefore, let me see if we can get it right. 3 minus 1 is 2. Therefore, if we go down here, we need to shift this one, this set of bits to the left by 2. So therefore, if we're starting from here, we need to move this 1 and then 2. Okay, that's why the 1 moves here. And if we look at the logical product, 0 and 1 gives us 0. Therefore, we don't need to add 1 to our R anymore. And you can do the rest if you got time. But I think that if you figure it out, you select the answer and then move on to the next numbers. And if you still have time, remember to review your answers. Maybe this one you can do the other numbers, 3, from 3, 4, 5, 6, and so on and so forth, if you're still uncertain. But I think in this case, I was able to figure it out enough to choose the correct answer, which is letter A.